Welcome and good morning, everyone. My name is George Hamilton. I'm the Director of Membership Development at the National Utility Contractors Association. And part of what I do at NUCA is to help members or contractors in different regions of the U.S. Start new NUCA chapters. And right now I'm working with contractors and some suppliers in the Mid-South region, so West Tennessee, North Mississippi, East Arkansas, to form a new NUCA Mid-South chapter. And so I'd like to thank you all for joining the new NUCA Mid-South chapter, and also our presenters from Hobos Pipe for their flexible pipe design and installations best practices webinar. This webinar actually includes 1.5 PDH hours for PEs. So if you need those PDH documentation form sent to you, we will do that after the webinar. Just put a message in the chat so we can capture that and make sure we send out that documentation to everyone who needs it. Just wanted to sort of talk a little bit about the new Mid-South chapter. This is a formation event for that chapter. It's meant to basically showcase the kind of programs and events that NUCA chapters offer to member companies regionally throughout the United States, and to help strengthen the utility industry, as well as the companies that are members. To help us ensure that the presentation flows smoothly today, I do ask that everyone who's attending keep themselves muted so we don't end up with background noise, and also to preserve bandwidth, if you could have your video turned off if you're not a presenter, that would be great. If you have questions, please go ahead and put those into the chat as well. Just make sure you're chatting to everyone, and we will monitor that chat, and we will either break in to the presentation if the question is particularly timely to that area of the presentation, or we'll cover them at the end of the presentation. I'd also like to take a moment to recognize and thank the Keystone founding members of the new NUCA Mid-South chapter. These companies have really stepped up as early leaders in the chapter formation process, and they are W&T Contracting Corporation, Magnolia Underground Construction, Sunbelt Rental Shoring Solutions, Bar Environmental, and national partner locations from some of our key national partners, including United Rentals Trench Safety in Bartlett, Tennessee, and of course our presenters today, Hobos Pipe. If you're doing business in the Mid-South region and would like to learn more about the new NUCA Mid-South chapter, I can tell you that the web address is www.nuca.com/midsouth. And also I will put contact information in that web URL into the chat shortly. So without further ado, I'd like to hand it over to Joe Tipton from Hobos Pipe, along with our other presenters. So welcome, and thank you all for being here today.
Thank you, George, and thank you, NUCA. What I'm going to do is introduce myself and my colleagues who are online with us today. And I'm Joe Tipton, as George said. I'm the area sales manager for Hobos Pipe. I handle Tennessee, Kentucky, Indiana, Michigan, and Ohio. I've been with the company almost 6 years. I came to Hobos from Hanson Pipe, which was their pre-stressed concrete cylinder pipe, bar wrap, and steel division. And I reside in Nashville, Tennessee. So, I've been there since like 1992, and I love Nashville. And on here with me from our company is Kimberly Pajoli, and she's a PE, a professional engineer with us, and vice president of our marketing quality control for Hobos Pipe USA. She has a bachelor's of science in civil engineering from the University of Connecticut, and a master's of arts and business administration from the University of St. Thomas, Houston, Texas. Kimberly has over 28 years of experience in the fiberglass piping system design and manufacturing and inspection. She's been with Hobos, in fact, for 30 years. So a lot of experience, a lot of knowledge from Kimberly, and we want to thank her for being here today. And also on here with us is John Simonson. He's our divisional sales manager for the South region for Hobos Pipe. And he has a BS in construction science from Texas A&M University, Roll Tide. Just I would throw that in there. He has 30,
All right, got to do it.
he has 38 years of utility construction experience, guys. So he's a vast knowledge of all facets of underground construction, from tunneling, TBM, tunnel boring, machine work, auger drilling, hand mining, CIPP, heavy utility contractor work. So John's experience is vast, and he's been with the company between 25 and 30 years with Holboss. His experience is laying pipe, in laying is jacking, tunneling, slip lining, CIPP, rehab, manufacturing of sewer interceptors and water mains. And this is over 36 years in general. So it affords a solid foundation for analyzing and constructability of projects, a vast amount of knowledge, which I have leaned on many times when we were working with engineers on design builds and situations like that. So without further ado, we'll kickstart this thing by handing it over to Kimberly. Kimberly, go ahead.
Great. Thank you, Joe.
You're welcome.
So, John, you want to?
Yeah, I'll do just a brief introduction here about we've been asked to address best practices on flexible pipe. So, and it's sometimes it's obvious, sometimes it's worth mentioning. We thought we would. There's rigid pipe, like reinforced concrete pipe, vitrified clay pipe, semi-rigid pipe like ductile iron, and then there's a whole group of flexible pipes, whether it be our pipe or steel pipe, PVC, HDPE, just a vast variety of other materials that do flex and need a different type of support system other than what rigid pipes do. So our whole intent here is to talk about flexible pipes, although our experience level is with Holboss fiberglass pipe, but a lot of what we're talking about is going to be applicable to whether you're putting in PVC or HDPE or any of those other materials. It's all about getting it in the ground in a way that keeps your production rates up, so that you as a contractor can make money, the owner gets the type of finished product that they're paying for, and everybody gets done with the job and they're happy with what's done. So that's our goal. It's an interesting concept of what some people think is flexible and what other people think is rigid. I got into a very good discussion with the Corps of Engineers group down in New Orleans when they were welding some 84-inch steel pipe for a pump station, to take all the rainwater and pump it over the levee. And they didn't want to entertain fiberglass pipe because it was flexible. And when you looked at this big 84-inch steel pipe with all these stalls in them that kept the pipe from collapsing on itself, because it was super flexible pipe. It was about an 8 pipe stiffness when you looked at the wall thickness, and it's modulus. So it was maybe 5 times as flexible as fiberglass was, but they didn't view steel as flexible, and they viewed fiberglass pipe as flexible, and it still working on the Corps of Engineers in New Orleans. But that's just what we want to address. There's all types of pipe, but the installation practices and how the pipe itself performs are unique to themselves. And Kim's going to touch a lot about what we do to understand our pipe in such a way that we can help you install it correctly and understand what affects our pipe in what you do in the field, what design engineers can do that affect the overall installation, and just how we can address this as a team to, again, get a successful result of the project for everybody involved. We're going to talk a little bit about intended use of flexible pipes, the different installation methods, because they do have different criteria that need to be addressed. And it all starts with proper pipe design. So is the pipe designed to do what you're trying to do with it in the field, or can it be modified for what you're trying to do with it in the field based on depth, based on soil types, based on the equipment they're using to put it in the ground? All those things we're going to touch base on, and they all revolve back to, if the pipe is designed correctly and it's installed per that design, then you're going to have a good result. And that's where Kim's going to come into and talk about all the governing regulations that help us as a pipe manufacturer and the owner and the design engineer understand more about the pipe and what should and shouldn't be done with it. So Kim, if you'll take over from here, I'll keep forwarding on.
Sure, great. Thank you, John. So
You bet.
I'm going to cover the next section regarding standards, pipe performance, and testing. And as John and Joe said, my background is in fiberglass pipes with 30 years experience relating to product design and performance. And although I'm referring to fiberglass a lot in this example, flexible conduit theory is applicable to a wide range of non-rigid products. So I'll just go through some of HOBOS's first standards. So we have some standards listed here. The fiberglass pipes are manufactured in accordance with US and international standards. And these standards have different requirements based on the application. So for example, gravity sanitary sewers are covered by ASTM D3262. And then if the application is for pressure, for example, or other effluents other than sewer, then there might be other testing that's required and outlined in these particular standards. So by choosing the correct standard by which to specify, that gives you therein the requirements for us to manufacture, test, and field test. So additionally, the pipes are tested in accordance with NSF Standard 61 for potable water, and it's certified by several agencies, including National Sanitation Foundation, UL, and BNQ. BNQ is a potable water authority in Canada. And our manufacturing facility in Houston is also 9001 and 14001 certified. You can go to the next slide for me, John. The structural design procedure for buried pipes involves first establishing the design considerations, selecting pipe classes and the corresponding pipe properties, and then selecting the installation parameters and the performance and performing the calculations to ensure that the design requirements of AWWA M45 are satisfied. So our engineering staff is able to review the project specific designs and make recommendations as to the proper use of the product. And this is a typical list of calculations that would be performed by us. And that can be adapted on a case-by-case job basis. Go ahead, John. So this looks a little bit complicated, but this deflection is the chief area of concern for most owners and engineers and obviously contractors during installation. And this depends on the pipe's stiffness. However, the pipe stiffness, how the pipe stiffness affects the product performance is very often misunderstood. If a pipe is over deflected in the field, and I mean any flexible pipe, whether it's fiberglass or PVC or HDPE, the first question is not what's the pipe stiffness, but what's the support provided to the pipe. So let me explain that a little bit more. When the pipe is installed in the ground, all flexible pipes undergo deflection, and the amount of deflection is a function of a lot of things: the soil load, the live load, the native soil characteristics of the pipe zone, the embedment materials and their compacted density, the trench width, haunching, all of these things, including the pipe stiffness. So when you look at the equation in the right hand side of this slide here, this equation has some components to it. This was the IO equation first published by Spangler, and it shows the empirical calculation for this deflection behavior. So basically, the top portion of this equation is the load, and the bottom portion is the support, or that which counters the load. So for any given loading condition, those two bottom components, PS, pipe stiffness, and F sub S, soil modulus, those are what affects the deflection greatest. So pipe stiffnesses are usually in the 46 or 72 range, as John said, for most direct bury products. And soil modulus depends on your specific installation condition, but it's somewhere in the thousands. So as you'll see on the next slide, the largest impact on deflection is the native soils and the embedment. And so go ahead and forward to the next slide, John. So again, the formula for deflection has the two factors in this denominator. one being pipe stiffness and the other combined modulus. For our typical installation, the pipe stiffness times its factor ranges from about 5 to 11. So this 1.149 times pipe stiffness gets you these ranges you see here, 18, 36, 46, 72 is going to get you this factor of 3, 5, 7, or 11. So that's the contribution to this bottom portion of the denominator by pipe stiffness, by the pipe. This right chart is showing you the contribution from the soil modulus. So depending on the installation type, the soil conditions you have, how many blows per foot in the case of granular materials, you have a corresponding modulus, M sub S, and this factor, 0.161 times N sub S. And this gives you values that range from about 3 to 180. So the magnitude of the soil component is far greater than the magnitude of pipe stiffness. So this means that increasing the pipe stiffness to combat deflection is not as effective as improving the embedment. And we get this a lot. If we see installations that have deflections that are a little higher than we had predicted, they say, well, can we just make the pipe stiffer? Not really. The most effective way to make this installation correctly is to increase the embedment. Go ahead to the next slide, John. So there's lots of other calculations that are verified as well. Flexible pipes are checked for all of these performance criteria, and appropriate safety factors are applied. So in addition to deflection, we check wall crushing, buckling resistance, and then when the pipe does deflect, it causes strain in the pipe wall. And this is something I'm going to talk more about later in upcoming slides regarding particularly the behavior of this strain on the product. Go ahead, John. So in order for a pipe manufacturer to accurately predict the performance of the pipe, the information about the actual installation is really what's necessary and crucial. So this includes the cover depth, the location of the water table, any other loads that might be applied, like live loads, and of course the support to the pipe. So in a direct bury application, this would be combined soil modulus, which is the combined support produced by both the native and the embedment materials. And then the predicted reaction can be compared to the allowable limits. Go ahead, Sean. And here is back
one too far, sorry.
Here is a summary of an analysis with the predicted performance versus the allowable limits. Now you can go ahead. And this is a stiffness test. The pipe production is sampled and tested in accordance with ASTM standards, and we perform a variety of tests depending on the application. So test results are always available from us, including stiffness and deflection characteristics, as well as mechanical properties such as tensils or compressions. And the next slide, we have a short clip of an actual stiffness test. This particular test, 72-inch, 72 stiffness, would take about a half an hour. So we sped it up to complete this in about 30 seconds. And I'm not seeing it play. There we go. So in about 20 seconds in, you'll see the failure occur on the top portion of the pipe. Yeah. Right there, we see the failure.
Sorry. Clicked the wrong button.
Yeah, that's okay. You can, if it goes so quickly, you can go ahead and play it one more time, and so that we can see it. So in this case, the deflection reached over 24%, which is well in excess of that 5%. So you can see this pipe is actually very flexible, even though the total load at failure for this particular pipe was over 10,000 pounds. So as discussed earlier, the load carrying capability of the pipe alone is much less than the combined carrying capability of the pipe soil system.
Yeah, and it's very, very important to recognize that for that pipe to be able to deflect in the vertical direction to actually get shorter, it has to get wider. So in this test, there's no side support, and the huge differences to what we have in an installed condition in the field is it does have side support. So it can withstand that load without going into a deflected state based upon how much side support there is on the pipes.
Yes, good point. So in addition to the short-term tests like the stiffness that we just saw, many performance limits are determined at extended periods through statistical extrapolation of data obtained from long-term tests under similar conditions. So one test is the ASTM standard for strain corrosion, which is this picture here. This test was first published by ASTM in 1978, and it requires that a minimum of 18 specimens are set at various strain levels over more than a 1-year test duration. So the strain corrosion testing was done per the sanitary sewer specifications in 1 normal sulfuric acid. So this mimics a very corrosive sanitary sewer. And these accelerated tests continue for a minimum of 10,000 hours per the standard, and the basis by which fiberglass pipes can be shown to have been shown to have a design life of 150 years. So go ahead to the next slide. So how are these test reports used to determine the expected life in such an environment, and how do we justify this 150 years? Well, this is how. First, the pipe design is resistant to sulfuric acid, which we all know is the demise of many traditional pipe materials. And this graph to the right shows the life expectancy of pipe. And we can very accurately predict by plotting this strain level versus pipe deflection versus this time to failure. So the time is across that bottom axis. And we have a tremendous amount of experience in this testing environment. Some tests have been running here in Houston in my lab for over 27 years. And globally, we have pipes that have been in this environment, in this test environment for 40 years. So when you speak about extrapolation to 50, 100, 150 year marks, we're really not talking about that which is much greater than the test duration we have, because this is a log extrapolation. So you see that the time to failure of 0.1 hours, 1 hour, 10 hours, 100 hours, 1,000 hours, that across that bottom axis. When you talk about extrapolating the current test data, all those blue dots are current, just 1 year tests, 14 months. Extrapolating those out to these 50, 100, or 150 years is really not that much of a stretch. It's really just a couple log cycles away from all of the testing that we've done. So that, I think the next slide is back to you, John.
Yes. And just to kind of give an introduction as to why flexible pipes are being used more than rigid pipes now, because there are other things that have to be considered with installations on flexible pipe. But pipes like PVC and fiberglass and other plastics are resistant to the things that make pipes deteriorate quickly. So I can't think of hardly any customers that are still using bare concrete pipe or even lined concrete pipe in sanitary sewer environments, because it just doesn't last very long. And so they're willing to incur some additional installation costs for flexible pipe because they get so much more life out of the system. And in today's environment, with the economy what it is and budgets what they are, the more life they can get out of a system for the same amount of dollars, or even a few more dollars, on bid day. If that system lasts 2, 3, 4 times longer than a conventional system, it's money well spent. So we've enjoyed the marketplace. We're growing along with all the other materials. And for those of you that are trying to find materials to buy and put in the ground, you can tell that everybody has been slammed with demands to to produce more pipe faster and get it to the job site. So, but I want to talk a little bit just about installations. And Joe brought up my history is I've loved utility construction for a long time, been in it for a long time. I've seen pipes like those shown on the left that were installed very shallow, which have their own criteria of concern, you know, for loading, flotation, some other things that happen with flexible pipe that are that shallow. I've seen this pipe installed and other flexible pipes installed 200-300 feet deep inside tunnels. So there's a lot of challenges, a lot of different environments that need to be addressed when addressing flexible pipes. And hopefully over the next 45 or 50 minutes, we'll get to touch on some of those. I'm going to talk a little bit about inspection when pipe shows up on your job site, what to look for, and again, whether it's ours or anybody else's, how to handle it, how to store it safely, then really getting into the meat of things on direct bury installations themselves, on what really needs to be focused on to assure a good installation. And then as time allows, we can get into two-pass tunneling, slip lining, other parts of flexible pipe that are used quite often, but really in what we've seen in the industry, maybe 85 or 90% of our business is in direct bury new construction. The rest of it is split up between slip line applications to renew aging infrastructure and direct jack tunnels. We're just that's the method that's needed to get the pipe in the ground without tearing everything up on top of the ground that's getting in the way. So we'll talk a little bit about good practices to put in, the pitfalls that you might see that you need to watch out for, some of the damage that could happen to pipe and how to recognize that, hopefully, and to prevent it, or if and when it does happen, how to repair it. And then we'll have some time at the end for questions and answers. And I hope if you have some questions along the way, go ahead and type those into the comment section, and want to make sure that we get as much of this addressed as possible. So just a brief minute on just the transfer of the product. So when the manufacturing plant produces a product, it's in our control, it's inspected, it's tested to make sure that it exceeds all the standards that it needs to be. For us, if our pipe is stamped 46 stiffness, it's over 46 stiffness, or if it's stamped 155 ton for jacking pipe, it exceeds that by a vast amount, because we don't want to ship anything to your job site that doesn't exceed the requirements for that job site. So when it leaves our factory and goes on the back of a truck, and that truck driver straps it down, that is literally his pipe at that point. It's no longer in our control. And whether he's driving 2 hours up to Dallas or he's driving 3 days to get out to California, he's in charge of that pipe, and things could happen to it along the way. So we get calls and photographs, not as frequently as we used to, which I think is a good thing. I think the truckers are taking more care of the pipe, but if they don't strap it down right, and especially like this picture here where pipe is on a drop deck trailer, if they don't strap this down right and this pipe is constantly sliding up and hitting that metal deck in front of it, they could damage the end of the pipe. That could cause sealing issues if you don't catch it when it shows up on the job site. But Randy Whidden, our field service manager, gave me quite a few slides to just talk about as a contractor what to look for in the field as you're building your project. And the first step is to look at the pipe when it shows up on a truck. I mean, I'm going to say 99.9% of them are going to be fine, but if you see one that's damaged, point it out, take a picture of it, note it on the bill of lading, because what we can do is when we come out and look at that pipe, if we've got to cut a few inches off of it or a few feet off of it because it's damaged, we're going to bill that to the trucking company. It's not going to cost you anything, and we don't want it costing us anything if the truckers didn't do something right, or if they hit a bridge when they were coming to your job site and damaged the top of the pipe. There's all kinds of things that could go wrong. So just be cognizant of the fact that when you take that pipe off the truck, it's now yours. So when you're taking it off the truck, make sure that it's not damaged, and certainly flag anything that is, and we'll either take care of it if we can repair it. If we can't repair it, then set it aside and we'll ship you a new one. But addressing that when it shows up and on the bill of lading is much better for all parties involved than having it sit on the ground for 2 months. And then as you pick it up to install it in the ground, you go, oh, by the way, I forgot to tell you that that pipe was damaged when it came off the truck. Then the trucking company starts arguing, well, I don't have anything on my bill of lading, and you probably dropped it, and it just gets into a whole mess that we'd all rather avoid. So just be good stewards of the pipe when you take it, because when you take it, it's yours. And that's a good lead in for this next picture. And I want to thank Bijan, our division manager out in the West Coast, that shares this picture a lot. This was improper handling of pipe. So I believe this literally rolled off of a truck onto that car. It wasn't hanging from an excavator or a crane. And this pipe, even though it's flexible pipe, it is extremely heavy, and it's dangerous to be around if you don't handle it correctly. And in this particular instance, they unstrapped the pipe and were from the truck. They were getting ready to put a strap on it and pick it up. The truck was parked on a little bit of an angle, and pipe rolled right off the side of the truck and gave this car a new profile. So nobody likes to see that. Just be careful with it. Handle it correctly. It is flexible. It's kind of hard to describe in a way, because if you took a section of this pipe and cut it into blocks, you'd swear they were bricks and you couldn't bend them, because it is a very, very stiff, flexible pipe. And especially as the walls get bigger or you get into jacking pipe, but it's still flexible. It's still made of plastic, and it's still reinforced with fiberglass. So try to avoid impacts, and I mean impacts like dropping it off the truck onto the ground, onto its corner, like it's shown here. I mean, even if this was concrete pipe and it fell for 4 feet off the back of a truck and just hit the corner off of a spigot or a bell, you would damage the pipe, and we don't want the pipe damaged because it's not going to perform the way that it should. Setting it on the ground in a nice even manner, not setting it on the pipe ends themselves. And in smaller diameter pipe, oftentimes it shows up in stacks so that you don't have it spread out over such a big area that it's stacked one on top of each other. Take care when you're stacking those to make sure, again, that they don't lean over and fall on the job site. And this is a great picture of some of the smaller diameter stuff that comes stacked, and it's sitting on its dunnage, keeping the spigot, the bell end and the spigot end off the ground. I've seen a lot of pictures or job sites where the contractors, as they're excavating the trench, they'll throw some dirt over here and make a little mound, and they'll have one mound here and one mound here, and set the pipe on a small mound of dirt, so that there's an airspace in between that allows them to get the straps around the pipe a little bit better. So just common sense handling and safety issues. I know that a lot of you have installed our pipe and other flexible pipes, and so this may be old hat, but for those of you that haven't, it just needs a little bit of extra care. Short-term and long-term storage. Short-term's easy. Get it off the truck, get it in the ground as fast as you can, and it's not an issue. Longer-term storage, where you're storing pipe on the ground for 6 months, 12 months, a year or longer. The exterior of the pipe is resistant to UV damage because it has a sand layer on the outside. But the interior of the pipe is not protected, so we don't want sunshine coming into the end of that pipe for long periods of time, because it will literally sublimate that resin and cause the resin to evaporate over time. If you've ever seen a fiberglass tank that's hasn't been painted, that's been sitting out in the sun for a long time and it gets fuzzy, that's because the sun has been working on that resin, turning it into a gas, and it's evaporated over time, leaving the glass exposed. And nobody wants fuzzy pipe put in the ground. So if you're planning on storing it long term, we've got a good group of people that come out as field service professionals, and they can examine the pipe. They can help you design ways to store it on the job site where it's pointing. I'm going to get this backwards. It's supposed to be pointing north and south or east and west, but you don't want the sun coming into the ends of it. So I guess it's pointing north and south, so that the sun's going around it versus going down the barrel of the pipe. So just a little bit of planning up front, if you've got room to do so, will save you some headaches further down the road. And being in Tennessee and Kentucky, I couldn't resist bringing up a little racing. This was a favorite movie of mine from a sales standpoint, because just being able to understand each other and each other's abilities and expertise is critical in this industry. As we want to be able to understand the contracting industry and how we can do better as a pipe manufacturer to help meet your needs, as well as the design engineer industry. And just like in this movie Days of Thunder, I mean, you can be the best race car driver in the world, but if you don't understand the car, you may not be able to finish the race. And this was just a great quote out of that movie, where probably the best guy in the world that can build cars or could build the best cars is talking to the best race car driver in the world that could just drive the wheels off the car, and they just didn't understand each other. So one of the purposes of this discussion is here so that you can understand more about flexible pipe, and that we can understand more about the challenges that you see in the field, because we don't want to slow you down. We want you to win the race. We understand that getting pipe in the ground as quickly as possible makes you money. It's been a few years since I ran a large diameter pipe crew, but I'm going to say that's 10, 12 years ago. A good sized pipe crew for laying 60-inch pipe was probably costing about $10,000 a day. With inflation, what it's been, and the cost of fuel and other materials where they are, that might be $15,000 a day now. So if you can shave every day, you can shave off of your installation schedule by doing it right the first time, is money that's in your pocket. And we all want you to be successful. Believe it or not, even owners that complain about the cost of construction, they want you to be successful. They want you to do your best on the job, as long as they're getting the product installed the way they want it installed. If you can do it successfully and make money, then more power to you. And we want you to do that as well. So we're going to talk about the limitations. We're not worried about you melting the rubber off the car, but there's just different things. If you're used to laying rigid pipe, and I've worked with a lot of contractors, that's all they've laid, especially in the southeast. I mean, they're ductile iron people, and they're used to laying ductile iron pipe, and they throw it in the ground and throw a little gravel on it and blow and go, and they never look back. You can't not do that with flexible pipe. But that doesn't mean that you can't do flexible pipe well. You can't install it fast, and it won't give you the advantages and provide the owner with the advantages that flexible pipe bring with it that rigid pipes don't. So how do you win the race? How do you do it with flexible pipe? And just so we're talking in the same vocabulary, and I'm understanding you and you're understanding us, that's what we're going to talk about here next. And it's all about keeping a tight pipe zone. And that's a Rick Turcopism. If you ever asked him about any type of a pipe installation that had a deflection issue, he'd always ask about the pipe zone. And if you keep a tight pipe zone, and we'll get to that picture that Kim brought up just a little while ago, it's the area around the pipe that is more impactful on the long-term performance of the product, more so than the stiffness of the pipe itself. Another thing that Rick used to say is he could take an aluminum beer can. He might not have said beer, but I'll say beer. Cut the ends off of it and bury it 30 feet deep without it crushing, if you do it right. And doing it right is what we're talking about here in terms of best practices. So keeping the pipe zone tight and compacted is absolutely critical with flexible pipe. We'll show you some examples of do's and don'ts and things that went well and things that didn't go so well. So the other thing that you have choices with when flexible pipe is the choice of embedment material itself, whether you're using cement stabilized sand, just plain native sand, if you're using pea gravel type rock that's smooth and flows well, or crushed rock that's 3/4 inch that doesn't flow as well, but is a great supporting material. Whether the material you're putting around the pipe is almost at its compacted density as soon as you dump it out of the bucket, or whether you've got to sit there and beat on it with vibrating plates, sheet split rollers, split wheel rollers, pogo sticks, jumping jacks. There's all kinds of ways to get that material around the pipe compacted. But as a contractor, you want that material to take as little time to get in its final dense state as possible. So if you can use a material that is in its dump density is almost its final density, and you have to put very little effort into it, additional effort to get it into its final state, then that's something you should be striving for. So nobody wants to sit out there with a handful of laborers required to go in there with small tools and beat the heck out of this material around the pipe to make sure that it doesn't move. There's better ways to do that. But the ultimate goal is to get that material tightly compacted around the pipe so that the pipe can't deflect. And that's what we're guarding against with flexible pipe. Guard against deflection, and do a good type installation. And we'll talk about this a little bit later, but you can do the best job in installing. But if this is a wet environment and there's groundwater that is migrating through this material and it wants to get in, especially if you're using a 3/4 inch crushed stone, and you're going to create a French drain here, miles and miles long, and trust me, as long as the pipe is, if the groundwater is going to find its way to its path of least resistance, and it likes that French drain and it wants to run down that French drain. But if it's pulling the soils, if it's pulling the dirt that's around that pipe with it, as it's getting into this pipe zone, you're removing material from here that will cause problems later. So I wanted to bring that up here, and we'll talk about it later, because it's a very fixable problem. If it's addressed, it's a very big pain in the butt. If it's not addressed, then it becomes a big issue later. Again, here's the same picture that Kim was talking about, and this is another Turkopism. Is he used these? He used the analogy of springs. So as Kim was saying, that the pipe stiffness itself, in terms of load carrying capacity, isn't as much as the embedment material that you choose to put next to it, or the native soil. And I'll use a couple of different examples. So if you're cutting through granite and you have a trench that you've either blasted or you've sawed or you've excavated in some other fashion, drilled and blasted, you've got a very good surface for this pipe to push against. And if you dump 3/4 inch crushed rock in there that's probably at 95% of its ultimate density as soon as it hits the bottom of the ditch, that pipe isn't going to go anywhere. It's a good pipe that has good embedment material to push against, that it won't compact. It has a good wall, if you will, over here of the native soil that it can push against so that it won't over deflect. And this system of the pipe, the embedment, and the native soil will be in equilibrium. And the spring that you get, or the resistance from the soil here, is much bigger than the spring of the embedment material here, which is much bigger than the spring of this pipe that's trying to dissipate that load. So things that we can control as a pipe manufacturer, we can control the pipe and the pipe stiffness. Well, the things that are in your control are the type of embedment you use, how you get it in here, and how well it's compacted. And the biggest thing is this interface between these two. And I bring that up because a lot of plans and specs that you'll see will show a native material that's consistent of material that might have 6 blows per foot, which is a very good soil to lay pipe in. But if you excavate that trench and you leave a bunch of loose material, or that soil starts to slough off, and now it's laying between that 6 to 12 inches sometimes that you might have outside the ditch box, and it doesn't get compacted back to 6 blows per foot, you've literally changed the equations that we've gone through as a pipe manufacturer and the design engineer have used to design this job around 6 blows per foot. So getting this native soil back to at least 6 blows per foot or better, and I'm talking about not just on top of the ground, not just what most owners concerned about is they don't want to see the ditch settle over time, but it's this interface right here between the pipe wall, the embedment material, and the native soil. If you get this compacted and you get this compacted, you will get a very long-term low problem or zero problems with the pipe material over time. And if you don't do that, and this is another Turkopism, if you don't compact the native soil that's sloughed off, or you don't get the material that you put between the pipe and the native soil compacted, the pipe will do it for you over time. As that picture of that video showed, as that load is coming down on the pipe and the pipe sides are pushing out, they will recompact that embedment material and they will refill that space that's left of the native material. And as it does that, it will find its own equilibrium. But every inch that it moves out, or every part of an inch that it moves out, is inches that it's deflecting in its vertical state. And we're only allowed 5%, so there's not enough room there to give away needlessly. The other part about the embedment, not just that it's densified, but just the area under the pipe, right here in these called haunches. You can dump material around the sides of the pipe out of a loader bucket. You'll get a lot of it that scatters in here, but if you've left a void, that's an area that the pipe needs some extra support. That's a lot of things that also the pipe stiffness helps with, because it can bridge some of this inadequate haunching. But there's some things that you can use as tools very quickly especially with crushed rock or pea gravel type material. Just a concrete vibrator. We've seen contractors that just have a generator in a small handheld concrete vibrator, and they'll walk down the sides of the pipe and hit it in 4 or 5 places with some vibration, and that vibration will cause that rock to settle down into these voids here under the pipe haunches. It takes very little time. I've seen some contractors that have actually manufactured their own equipment where they've got a huge fork that has 6 rods on either side of the pipe that they pick up, and it has a hydraulic vibration unit with it, and they very quickly, and I mean in a matter of less than a minute, vibrate that material that's on the sides of the pipe. And you can literally watch it on the side of the pipe, and it'll shrink maybe 1/4 of an inch. Well, for that pipe to shrink to that vibration means that it just moved into all those spaces that weren't full of rock yet. And it's closed those voids as tight as they're going to be closed, and it allows that pipe a great surface to push against. I've seen other contractors that will use variations of a sheep's foot roller as a split wheel where they're rolling on either side of the pipe. Most of that's done outside of the ditch box as the ditch box is pulled forward. Contractor will come in there and re-densify that crushed stone and help recompact that soil that might have sloughed off outside the ditch box. Other contractors, and I think we have some pictures coming up that show different ways to handle the tail of the ditch box to reduce the amount of space that there is, or void space, so that it's all compacted. It doesn't take much time in the scheme of things. It actually doesn't take that much effort, but those little things that you can do, if it saves you having to come back and dig up some pipe and recompact it and put it back in the ground, that could take hours or days, those few extra minutes you spend compacting the material around the pipe saves time and money in droves. Joining pipes, pretty self-explanatory. Lots of different ways to push pipe together. This was one of Randy's. Just the key here is don't damage the pipe as you're pushing it together. Use a cushion, board across the end of the spigot. Most contractors and operators, they'll use a sling to set the pipe in the ground, and then they'll bring the bucket down and curl the bucket, and the forces against that sling will actually send the pipe home. Excuse me. However, the larger diameter pipes take a lot more pounds to get them to go home, and sometimes you'll have to have a timber across the end of the pipe and use a little bit more force to get the pipe to compress the gasket and to go home and to make a seal. So getting installed so that it seals, doesn't cause any leak, doesn't let the effluent out into the environment, doesn't let the groundwater that's in the environment into the pipe is all the goal that we're looking for. And I don't know how if you can see in this picture this black material here. This is a very sandy ground that's close to a river. There's going to be groundwater here. I think the contractor actually had some dewatering running in the background. This is filter fabric surround that will keep material from migrating into this crushed rock material and bringing fines with it over time. Other methods used are clay dams. Every so often, instead of crushed rock around here, it'll have clay. Some owners require flowable fill or concrete just to impede the movement of groundwater over time. Lots of good ways to prevent bad things from happening. Another more obvious than not thing to mention is just keep the gasket material clean. If you've got rocks trapped under the fins and you're trying to put the pipe home, the gasket can't compress like it should, and it'll cause a leak that you'll have to address later. If your crew is trained to clean that gasket out right before they lubricate it, there's actually somebody down in the ditch watching as the pipe goes together, and he's checking to make sure nothing gets knocked in there, or has the authority to stop, a pipe from going home if he does see something and get it fixed. Again, spending a few seconds to get it done right versus having to spend hours and thousands of dollars to go back and address it later is paramount. And not only with our pipe, but with lots of pipes. I mean, there's sometimes you're laying pipe on a radius curve that it has to be deflected once it's put together. And this is a different type of deflection, an angular deflection versus deflection from loading. If you've got to turn this pipe 1.5 degrees per joint, you have to put the pipe together straight. And then once it's together straight, then you can pull it 1.5 degrees. It's hard to put it together at an angle. It doesn't want to go together at an angle. You might damage the gaskets if you try to put it together as an angle. So just kind of a best practices thing, leave yourself room in the ditch to put it together straight, and then pull each joint over a little bit as it needs to be to go around that angular deflected radius. I'm going to play this. I don't know if I can pause it. I tried to pause Kim's earlier. This is just a real quick picture of pipe going together, and I just wanted to kind of highlight what I've already said here graphically. As the pipe is going together, and I want to stop. Yeah, I did stop it. As the pipe is going together here, it's compressing the gaskets of these fins on this gasket, and this is what makes the seal on the pipe. And there's two gaskets here, and then a long space and a center register. And you'll see these gaskets. This is where the seal is. This is where you're stopping leakage. This keeps groundwater from coming in this way and getting its way into the pipe, keeps effluent from coming out, getting past these gaskets and getting out into the environment. So this sealing surface here, the cleanliness of the pipe on the ends of the pipe where this is sealing against. I watched one contractor laying pipe out in Amarillo, smaller diameter pipe. But they were just laying the fire out of this pipe. I mean, they finished the job almost 2 months ahead of schedule. It was supposed to take 8 months to put in. They got it done in 6. And I just wanted to go out there and see how they were doing it so quickly. And they were actually taking more time, in my opinion, to get ready to put pipe together and cleaning. Literally had a 5-gallon bucket and a rag, and they were wiping the outside of this pipe off before it went together because it had dust and sand on it. And I talked to the superintendent and said, "Why are you doing that? I've never seen anybody do it." And he goes, "Well, if that stops me from having to go back and spend a half a day addressing a leak, it's well worth it. We keep the water down there. The guy knows what he's supposed to do. It doesn't take any additional time. He's got time while they're picking the next pipe up or moving the ditch box. And we just taking our time to make sure that everything's done right so that we don't have to address it later." One other thing about this type of a gasketing system, didn't let me do it. Versus other types of flexible pipes, you can't overbell this pipe. If you're in a tapered bell where pipe is going together and you push it in too far, and because this is tapered, as you're pushing the pipe into something that's not accepting the same diameter, you can split bells and cause leaks. You cannot overbell Hobos pipe simply because of the design of the gasketing system that will have the pipe pushing end to end against itself versus trying to put any kind of exterior force against the gasket. And if it'll let me do it one more time. Yeah. Even in the larger diameter pipe, the taper on the end of the pipe is bigger than the center register, so these pipes will butt up to each other. But if you're on the inside of the pipe looking at it as an inspector, as an owner, as a contractor, again, this isn't where the seal is. The seal is back here. So if you see a gap here, you're allowed to have an inch gap, which gets you to about here on either side of the center register. So these pipes could be 2.5 inches apart. They're still going to seal because of the gasket that's back here. But if they're touching, you're not hurting anything either, and you can't overbell it. So get it home. They're also marked on the outside. There'll be a black stripe out here on this end of this pipe, so that when the black stripe gets to the end of the coupling, you know that it's pushed home. Another thing about inspection, let me start that up in a more positive sense. Establish very early on in the first 100 feet of what you're putting in the ground, a practice that's going to work for that soil, that embedment in that pipe. I've been on a lot of job sites where I've made a gauge stick or gone up to Home Depot and bought an 1.5 inch piece of PVC and put caps on it at 97% of the pipe's ID. Or 98% of the pipe's ID. If you can make a gauge stick that's 2% deflected, keep that in the ditch with the guys that are putting the pipe together and check that pipe. The one good thing about flexible pipe is it will tell you instantly if you're doing it right, if you're getting the compaction right, if you're getting that density around the sides of it to give it the support that it needs right. It's instantaneous. As soon as you load this pipe, if you've got good support around it, you'll be less than 2% deflection. If it doesn't have good support about it and you're measuring 2, 3, 4, 5% deflection, believe it or not, there was a job in Arkansas that went to hell in a handbasket that the inspector was signing off on pipe that was 8% deflected the day it was installed. And it took several years for them to realize that was not a good installation. They had leaking issues and they're going back and addressing it now. But check that as you go. And we've had a lot of owners that understand this. We help train owners and engineers and inspectors to what to look for, as well as contractors, because we all want to make sure this gets in right. And if you get it done right in the first 100 feet, then just keep repeating that and keep doing that check as you go. Do it at the end of the day, do it at the, every 5 joints, whatever it is. If you're doing it right, the pipe will tell you you're doing it right. If you're missing something in terms of compaction, the pipe will tell you that too. Now, our rigid pipe competitors use that as a disadvantage. They're going, hey, this pipe's going to deflect. But you won't know if you've done an inadequate installation on rigid pipe for years to come. If it's thrown in the ground and has very little compaction around the side of it, that pipe's going to move over time, especially in wet environments like Houston. They've actually had pipe that's disappeared. The ground was so bad that they've gone and inspected and there was a piece of pipe missing. It just sank. It takes some time to see that with rigid pipe. You're going to get as a contractor that you're out there in the field with the equipment that you need at the time that you're out there working with it. You're going to get instantaneous feedback that says, look, I know pipe is going in the ground right. I know it's going to last for a very long time. And you can test the joints as you're putting them together. We would recommend doing that again as you're going. Get something established for that first 100 feet and just repeat that good process with good feedback, and then test and verify. Just get it going right and keep it going. And again, we have people that we can send out in the field that can help you do that. The things that we recommend everybody avoid, or everybody that does want to avoid, is just over deflection. You don't want a loose trench wall. Particle migration, those kinds of things that can cause flexible pipe to over deflect. Again, they're easy to identify, easy to correct. Just make it the joints, you want them to go together correctly, well lubricated, so you're not damaging the gasket. And then just the common sense stuff like stuff gets damaged on the job site. Don't put a piece of damaged pipe in the ground, set it aside, call us. More often than not, way more often than not, we'll come out and repair pipe at no charge, because we want that to be a good installation as well. We can fix dings and damage and broken ends quite easily, or help you trim them back and have very little waste on the job site, because it's everybody's best interest to get this installed in the best way possible. Now, here's the biggest pitfall for any flexible pipe. Actually for any rigid pipe as well, is just migrating soils. This has been addressed in design guides, from clay tile pipe to concrete pipe to ductile iron, PVC, fiberglass pipe. Everybody talks about migrating soils, but every once in a while, there'll be a design engineer that completely neglects the fact that they're installing pipe in a very wet environment with fine soils that will move as the groundwater moves. And this is an example of groundwater coming through very fine grained soils. And I mean fine grain that the particles, with the silts, the fine sands are smaller than the space between the embedment. So 3/4 inch crushed rock has a lot of airspace in it. The groundwater will find that airspace because, again, it's under pressure and it wants to find the path of least resistance. As the groundwater is coming through that soil, it's bringing soil with it. And over time, as that soil is brought through the ground, as the soil leaves here, it's leaving a void. And again, over time, that pipe is still under load. It's still a big spring that's pushing against this gravel. And then this gravel gets pushed into that void space that was left by migrating soils. Every time that there's a big rain event or the groundwater comes up to a certain level, or if it's constant, or if there's not any clay dams to stop the groundwater from moving through that trench, over time, this pipe will continue to deflect, continue to recompact this and find that equilibrium that it wants to be in until some point where it's exceeded its ability, its maximum deflection capabilities, and it fails. But and that's again, it's easy to avoid, it's easy to recognize, and this is a great example of a project that had an issue with migrating soils. This was a very long project. I think it was over a mile long of 90-inch pipe, and for about 400 feet. I mean, this was all good clays, very dense, no groundwater encountered as the contractor was installing the line, although it was in the middle of summer in a drought. Well, over the next 13 years, this one section, this 400 feet of ground, was just pure sand. And right on the other side of this levee, about 50 feet away, is the Trinity River. And we were able to go into the Trinity River's water elevation cycles. They measure all that stuff. How often that river came up above the top of this pipe, and it flooded this place, on occasion. But over 11 different flood events, the water was way higher than the top of the pipe, and this sandy area of the project was just a big soda straw that allowed the river to migrate through here and run down this gravel. And as it did, it was carrying this material with it. And then the pipe was, again, recompacting that material, and there were 3 or 4 joints of pipe right through here that over deflected and broke over a 15-year period. This project had zero protection for migrating soils in groundwater. I take that back. When it was designed, it actually had filter fabric designed around the pipe zone to prevent that. Somebody along the process between when it was designed and when it was bid was complaining about having to deal with filter fabric, and the owner decided to take the filter fabric out, and they had a failure here. And it's quite obvious. I mean, the reason this is sloughing off is because the groundwater is being pumped out and it's taking material with it. So as that material is removed, this material's again taking the space of that void, and it's just a very weak condition. And I'd show you another picture where all these plates are literally leaning in. It was a very unsafe environment, but they finally went back and took these plates out, put a ditch box in there so people could get in and work. But this is just a great example of what can happen with moving groundwater if it's not addressed in the design. And as contractors, as inspectors, as owners, man, be the first one to raise your hand and go, hey, I see an issue here. We weren't anticipating groundwater, or we weren't anticipating a sand seam here. Maybe we should stop now, address this with some filter fabric or flowable fill, or, I mean, you can even take, instead of having open spaces between this rock, go ahead and fill that in with fines so that you don't have a place for the soil to get in here and take up space in the embedment. And if it can't take up space here, it's not going to leave the place here. But, point those things out, spend the extra time and money to get it done as you're there. I mean, most owners will pay for that. And if you explain what's going to happen if they don't, I'm sure they'll jump on board with getting that addressed, because nobody wants to see that type of a failure. And again, it's in everybody's flexible design handbook in terms of what happens as the material leaves, and really what it is that the migration can result in a significant loss of pipe support and increasing deflections that could exceed the limits of the pipe. If you don't have that side support because it's left from that groundwater, the pipe is going to over deflect. It's inevitable. So fixing that with filter fabrics, with tight pipe zones, with well compacted material is the way to go. This is I was going to do the good, the bad, and the ugly, but we didn't have a bad. We had a really ugly one, and we had two good ones. So just there's a lot of room on this job to lay the angle of repose on the existing soils back. Had plenty of room to work and get compaction equipment in here. They had split wheel tampers that compacted this cement stabilized sand. This is a great install. This pipe really doesn't care if it's 30 feet deep or 3 feet deep, as long as it's well compacted and has something good to push against. As long as it's in that equilibrium, it's a happy camper. This particular contractor, Joe, I think this was Bowen Engineering's job. We went up and visited them in Indy, and this is the first time I saw this. They had some street plates tacked to the back of their box. So instead of having a 6 or 7 inch gap here between the embedment zone around the pipe and the soil, they were literally overpouring the rock so that this space here was being filled with rock instead of being left as a void. And then they tapered this back to like a 1 inch street plate, so there was really very little room for this rock to have to move once the ditch box was pulled forward. And then their compaction equipment came in here and really redensified this area on both sides to make sure that this pipe was tight. And they laid that whole job without a single piece of pipe getting over 2% deflection. Absolutely fantastic job. And it was a wet job too. They were pumping water out of there and fighting through some sloppy ground as they went. So there's been hundreds of thousands of feet of flexible pipe installed in very poor soils, from the swamps down in Louisiana to coastal shores along Houston that's nothing but wet running sand, to everything in between. So it's really just a matter of identifying what's there and as Kim was showing in that table, adjusting what's happening here between this embedment and the native soil itself, to get a good solid material for that flexible pipe to flex against. This was another job, and I took a black box and covered up the contractor's name because I don't want to embarrass them, although they're not on this call. This was a job that was done extremely poorly. There's huge voids outside of this ditch box. All the clay material is just sloughing off and filling in here, and it's all wet. There's worse pictures here where this is just a flooded environment. That was laying the pipe in almost a half a pipe full of water. Well, anybody that knows anything about laying, working in soils and trying to compact soils, you can't compact mud. And they literally laid this pipe through mud, left open voids of mud, put very little gravel around the pipe, just pulled the ditch box and said, hey, that's what the plans show. That's all I'm going to do. And they ended up having to come back and relay a lot of this pipe because it was over deflected after 30 days. Because like I said, you load this pipe, it's gonna push and push against whatever this material is and recompact all this stuff itself. And you don't want that to happen. You want to keep a nice tight pipe zone. And if there's anything that you remember out of this presentation over anything else, is a tight pipe zone with flexible pipe will save your day. I think we're okay on time for just a few minutes. I'll go through slip lining real quick. Again, with flexible pipe, there's just different things that you need to take into account. One of those is really just about what will fit through a line. This was just a terrible slip line job, and you can see a multiple S curve where the pipe's coming in this direction, and then it turns and goes this direction, and then it turns and goes back, and then it turns and goes another way. There's ways to slip line and to use different pipe lengths and installation techniques to get pipes through hosts that look like this or hosts that look long and straight. You want to use and excuse my high school math here, but I was taking notes from a lesson that Rick was giving me when I first started, and I thought it was so important I wrote it down, and I've carried with me ever since. If you've got a curve that has a given radius and a given length, it's very, very simple high school math to figure the geometry of what is the longest piece of pipe I can get through that curve. And really it's the biggest box that you can put in there, where it's touching here at the midpoint and it's touching at these points. And it's just basic math to figure out, hey, how long is this, can I get a 20-foot joint of pipe through there? Can I get a 30-foot joint of pipe through there? And you just take the OD of the pipe plus whatever safety factor you want, whether that's an inch or a half an inch or 4 inches, whatever it is you're comfortable with that you want. And that's the width of your box. And then what you're going to solve for in this equation is what is the length of that box. And it's just simple math. It's trying to figure out what that angle is, and then you can solve for half the length of the box. In this example, half the length was 11.22 feet. So that means I could get a 22-foot joint of pipe through that radius curve with 1 inch of clearance on both of these corners and this point, which means a 20-foot joint will fit through there, which isn't the end of the calculations, because you also need to know whether that 20-foot joint of pipe will seal against the next joint that's coming up against it. And again, in this example, I think the curve length was 230 feet and had 22 degrees of turn from start to finish. And if the pipe, whatever pipe you're using, in this particular example, it had 1 degree maximum deflection per joint, which means I could use no more than 22 joints in this section, which means they have to be less than 10.45 feet in length for them to be able to seal. So even though I could get a 22-foot joint of pipe through there, I could only use 10-foot joints to get them through there and also have a good seal so that they don't leak. We do a lot of pipes and curves, tunneling, slip lining. Flexible pipe is a great conduit here, again, because of its long-term resistance to corrosion, its leak-free nature. Flexible pipe can be designed differently by application. So a lot of people think of flexible pipe as something that's not very strong, but in jacking applications, for fiberglass pipe, you can beef this wall up, and these are the safe jacking loads in tons that you can apply to that pipe without it failing. And they go into the thousands of tons. So even though it is a flexible pipe, it doesn't flex by much. And we want to know where that pipe's going to fail. And again, I said earlier that we don't ship anything out of the plant that doesn't exceed its capacity. We love failing pipe in the lab. We don't want to see any pipe fail in the job site. And for slip lining and jacking loads, and this is probably going to end up being another discussion for a later time, we'd like to do one of these on slip lining and jacking. If you're pushing one pipe against the other, that the tonnage that's shown for any pipe is considering that pipe is in full face contact, meaning that the pipe is touching the next pipe evenly. This whole circle is in contact. If you're cutting this contact area in half, that means the allowable tonnage is cut in half. Or if you've only got 10% of the pipe touching each other, then you really only have 10% of the allowable load. In terms of installing pipe in a slip line application or a tunnel. And there's lots of different things you can do as a contractor in terms of intermediate jack stations, whether you're pulling the pipes in one at a time, carrying them in one at a time, pulling them in with a cable in a string of 3, and then installing them and going back getting the next 3, so that you're reducing the amount of load that are on those pipes, so that you're matching your installation practices to the capabilities of the pipe. You don't want to exceed their capacity to take that load, because you've reduced the amount of surface area of those two because they're open going around a curve. We can help with these. We can show you examples of a lot of contractors and what they've done. A lot of different things to look at. These intermediate jacking stations are a marvel. Back when I was doing this 30 years ago, we still had intermediate jacking stations for long tunnel runs, just because we didn't have enough rams in the back of the pit to push a very, very long string of pipe. And so we had to have intermediate stations that did just push this pipe in an inchworm fashion, and then retract those jacks, and the ones behind it would push, and so forth and so on. Things about blocking. I'll skip through these and get to the questions because we are just about out of time. I don't want anybody to be afraid of flexible pipe. Again, it's just like the tires in racing. The tires are soft because they provide better performance. They provide better grip. But if you don't take into account you're working with a softer tire because you get better grip out of it and better overall performance, you can damage the tires inadvertently. So with the right kind of practice, the right kind of assistance, the right kind of care, you can get a very successful, very fast installation process with zero leaks, with zero over deflection, that gives the owner what they want, that gets you off the job site faster, that saves you time, which saves you money in getting the installation done right the first time. And I hope we've addressed that. And if we haven't, if you've got something that I haven't talked about, if we brought up something that you're going to call, you want to throw the flag on and go, I don't believe that, now's the time to do it. So, George, if you've got a list of questions, or you want to.
Well, we did have Wiley from W&T Contracting posted a question in the chat a little earlier. Wiley, do you want to go ahead and unmute yourself and ask your question?
Sure. My question is about air testing. What is the recommendation on air testing? Would you kind of air test each joint, or what's the thoughts about air testing?
Great question. I like testing each joint because flexible pipe isn't going to leak through the pipe wall itself. If there's going to be a leak, it's going to be at a joint. So testing the joints are going to be the way to identify, especially with air, a leaking place. And I was trying to bring up this picture of this gasket. A very low pressure air test will show a leak better than a high pressure air test. And let me explain that. If I can get this video to play and stop it, hopefully it'll graphically make sense. The more pressure you put on an air tester, the more pressure you're going to put on the gasket to make a seal. Now, pause too long. One more try. Keep it here so it doesn't move. So we recommend a 5 psi test. Some owners recommend a 3 psi test to see if this gasket is going to seal. Because what happens is you're putting air. You're going to have a joint tester spanning across these pipes when they're together, and you're injecting air into these voids against this fin. And the more air that you push into that joint tester, the tighter this gasket is going to push against the pipe. So if you did a 50 psi air test, you're pushing the heck out of these gaskets, and you're making a very tight seal that's probably not going to leak. Even if there's a big rock or something under here, you could literally push that gasket around that rock and stop the leak by using too much air to test against. If you're using 5 psi, that's not a whole lot of pressure, and it will, if there's a leak, if there's something that this gasket didn't get compressed because it has something behind it or debris, it will show up in a very low air pressure test. I don't like the testing from pipe from one segment to the next, or manhole between manhole, because if you do find a leak, what are you going to do next? You're going to stop and go test into each individual joint to see which joint it was leaking. Just do that the first time. And 5 psi in a larger diameter pipe is tons of force. A lot of square inches on the end of a 96 or 120 inch pipe. And when you put 5 psi in there, or 10 psi, or sometimes the owner wants as much air pressure on the inside as there is groundwater on the outside, it gets dangerous to get inside there with a plug. Then it's just a big air bomb ready to go off. So hydrostatic testing is another good alternative, where if they do want to test section to section, use hydrostatic testing where you load it with water instead of air. But nowadays there's several manufacturers that make an internal line tester, air tester, that also has a mechanical deflection ring on the outside of it. So as you're pulling this tester through the line to test each joint, it's also passing a deflection test because of the gauge ring that's on the outside. So you can kill two birds with one stone. Test it for deflection, test it for joint seal as you go through, and hopefully the last day you install pipe and pull the tester through and test those last joints, you're done. Good question. Anything else?
Well, I mean, I'm sort of wondering, like, what are the biggest challenges to installing the flexible pipe and that the industry needs to get behind? So what can the industry do as a whole to get behind this?
Right. I'm trying to lobby for more owners to understand that there's a there's a difference between what's shown on the plans and what's seen in the field. I know a lot of owners like to say, hey, here's the plans. You've looked at the job site for, an hour. So you absolutely know everything in the world you're going to need to know about this job site, which is impossible and laughable. Even the design engineers that have worked on the job for a year or 2 years know more about the job sites than the contractors that are looking at it, and bidding the work. So I'm lobbying for contractors and owners to come to a more flexible understanding of addressing issues in the field. So if the job, again, like that job that had the issue with migrating soils, if you come into a situation where it's just obvious, hey, we need to do something different here, that you can do something different there very quickly. And whether that's with contingency items built into the job up front, whether it's increased amounts of crushed rock underneath it if you get in a particularly wet environment, just things that make it easier for the contractor to address those things that are probably going to usually come up, that aren't covered in the plans and specs, so that a contractor can keep moving, because as a contractor, that's your goal. Keep moving, keep that machine installing pipe, because you don't get paid to have the machine out there running. You get paid to have pipe installed in the ground. That's your pay item. So having to stop and have a discussion for the first time about migrating soils and groundwater when people have been addressing this issue for the past 50 years is a waste of time and money. So as an industry, let's figure out a way that we can get those things addressed quickly, get through them, get paid for the extra work, and get on with it.
Awesome. Does anyone else have any questions? I think we can handle, just if you have a question, go ahead and unmute yourself and go ahead and ask it.
I'll throw one out there. John. Can you touch on another importance that we are seeing less and less of when plans are made and jobs are ready to bid? We're seeing less geotech reports. What's the importance of knowing what we're putting the pipe in?
Yeah, as a contractor, it's vital, and I guess there's two different camps of thought here, and we get to work on both sides of that, because we work very closely with design engineers and owners as well as contractors. So owners don't want to get caught by a surprise. They don't want to bid a job and assume it's all nice, good ground, and then come to find out there's 30% of the job is just, crap, because they didn't have a test sample that picked up that, landfill that nobody knew about, or that pocket of silty clay that nobody knew about. But it doesn't do any good as an owner to ignore that either. So you can never do enough soil testing in advance. I mean, if you do one every 1,000 feet, there's 1,000 feet you don't know about between the two. If you did one every 100 feet, there's 100 feet between them that you didn't know about. Now, as a tunnel contractor, I've tunneled into old railroad pilings. Nobody knew there was a railroad through there, 100 years ago. And when they took the railroad out and the berms out, they left the trestles in there and just backfilled them, and then we had to tunnel through them. So there's a lot of owners are going through like a geological baseline. They'll have a certain set of samples of what the geotech is like and some assumptions. But as soon as the assumptions are not met, if there's something that's different, man, it's time to talk about it and come up with a plan to address it. And if that plan means that you got to do things a little bit differently, then by God, let's address those as a team as to why it needs to be done and how we get paid for it. I don't like projects that don't have any geotech, or, hey, this is just like the job we did 30 years ago, 100 feet away, because things change. It's very little money up front for the design engineer and the owner to to get some good geotechnical information about the job. And even as a bidder, when I was a contractor, you know, and I know it's hard, but sometimes if you don't know about the ground, you got to kind of assume worst case. And then your bid may be too expensive to the owner. He's paying for things that they don't need, which is great as a contractor because you just made a bunch of extra money. But the bigger challenge is if you don't want to take that risk, or you can't take that risk because you know there's 3 other contractors that are going to roll the dice and you might need that job. So now you're taking on risk and hoping the ground's not bad. And if you get into bad ground, what are you going to do? It's there's got to be a better partnership, and I don't know if that's more evaluated proposals or other things other than just a hard bid that doesn't address these kind of issues very well. I think there needs to be a better teamwork environment to get a job done correctly and everybody come out successful on it.
Wonderful. Well, if there are no other questions, I just wanted to, express my thanks and the thanks of NUCA and the Mid-South chapter that's in formation to Hobos Pipe and all our presenters today. I think this is a great event. Again, it's an example of the kind of event that NUCA chapters provide to their members on a regional or local basis. So professional education, but also chapters, through their connections and relationships that members build, businesses grow. And, in addition to that, you've got benefits like regional workforce development activity, leadership development for members of your team and your company, safety enhancement programs, and of course, networking, social events are all things that make NUCA chapters really important to the industry and to the companies and professionals in the industry in local and regional areas. I just also wanted to mention real quickly that NUCA is having their National Signing Day on May 12th. So by joining NUCA and NUCA Mid-South chapter, if you do business or are located in that area, you'd be able to sign up for membership for half price for the rest of the year. So, starting in May, you'd get half price membership for the rest of the year. And I did place in the chat my contact information and the information for the website of the new NUCA Mid-South chapter. Also want to thank the folks who are already members of our established chapters in Middle Tennessee, East Tennessee, and Kentucky who joined us today. And of course, again, our great partners at Hobos Pipe. So thanks everyone for coming. Again, my name is George Hamilton, and you can reach me at george@nuca.com. Thanks.
Thank you, George.
Thank you, George. Thank you, everyone.